Okay, we are continuing our lessons on circles. Today we are going to talk about arcs, which is a portion of a circle, and central angles. So first we're going to start by defining what a central angle is. A central angle is an angle with its vertex at the center. So that's a nice definition because it is what it sounds like. A central angle has its vertex at the center of a circle. Remember when we name an angle, we use our angle symbol, and we name 3 letters. The vertex must be the middle letter. So our vertex in this one is O, which is the center of the circle. A minor arc is an arc or a portion of a circle across from a small angle. It has to be less than half of the circle. So in this picture, we would then be talking about the portion of the edge of the circle, or like the pizza crust that goes from A to B, is less than half of the circle along the edge of the circle. The way we name that is by using its endpoints and putting a little curved hat above it. So like we put a straight little line segment or a straight line above it. Hopefully it'll catch up here in a second and we'll get that symbol up there. But just a little hill over top of it. Hopefully it'll catch up. It's been a little laggy today. Here it goes. Oh, let's try in. Oh. It'll be there in just a second. Oh, maybe not. Now it's reconnecting. I'll try again.
Got a little bit.
There it is. A major arc is more than half of the circle. Okay, so one way to say we have a major arc would be to go, instead of the quick way from A to B, the long way around from A to B. But the way we're going to denote a major arc to tell somebody that we want to go the long way is by giving a third point that we tell them they have to pass through. So a major arc will be named with 3 letters, and I could name that major arc A, C, B, telling them start at A, pass by point C, and land at point B. Okay? A minor arc just uses 2 letters, and that tells somebody go the quickest way possible between those 2 letters. When we bring in that third letter, that gives us a pass-through point. So I start at point A, pass through point C, and end at point B. A major arc must be named with 3 letters. A semicircle has its endpoints on the diameter, so it's exactly half of a circle. We would still use 3 letters to name a semicircle, because if you just gave the 2 ends, we wouldn't know whether you were talking about, for example, like the top half or the bottom half of the circle. So you'd still need to use 3 letters on a semicircle, but the 2 letters would be on the diameter. The measure or the size of a minor arc. Oops. The measure or size of a minor arc is the same as the measure of the central angle. So if I knew this angle was 50 degrees, then I would say the measure of arc AB is also 50 degrees. The measures of arcs are in degrees, and they are the same as the central angle. The major arc then, which with our drawing, we had defined as a CB in this picture, would be 360 minus the minor arc. It's the rest of the circle. So a whole circle is 360. If the short way from A to B is 50, then the long way would be 310. A semicircle being half of a circle would be exactly half of 360 or 180. Your problems tonight are going to be mainly concerned with this, the relationship between a central angle and its arc. Adjacent arcs are two arcs that are directly next to each other, sharing exactly one point in common. So they don't overlap, they are just right next to each other. So from our picture, I would say arc AB and arc BC would be adjacent arcs. They're right next to each other, they share point B, but nothing else. They don't overlap each other at all. Our arc addition postulate says that if you have two arcs that are right next to each other like that, you can add them up and find out how big the bigger arc would be, the arc from A to C in this example. Just like earlier this year, we had our segment addition postulate that we could add up two segments right next to each other, or we had our angle addition postulate that we could add up two angles right next to each other. We can also add up two arcs right next to each other. So if we knew how big AB was and we knew how big BC is, then we could add them up and know how big AC is. For two arcs to be congruent, they need to have the same measure and either be in the same circle or be in two circles that are the same size or have the same radius. Otherwise, if you would have like a little tiny circle and a bigger circle, we couldn't really say that arcs are going to be the same in those. Right? So they have to have the same radius and the same measurement of degrees. Theorem 9.3 says that two minor arcs are congruent only if their central angles are congruent. Okay? The relationship between a central angle and its arc is that they're exactly the same either way. If we know the arc, we can know the angle. If we know the angle, we know the arc. The only way that they're the same is if the other part is the same. So some examples. How big is arc AB? 50. The same as the angle across from it. How big is arc AC? 130. That's our arc addition postulate that we could say AB is 50, BC is 80, and we can add them up and get 130. How big is ABD? That gives us a pass-through letter. So we start at A, go by point B, and end at point D. How big would that be? 180. So we add up through all those three angles from A to B is 50. On to C gives us another 80. And on to D gives us another 50. Added up is 180. Which means that our ABD is a what? Semicircle. Okay, you don't have to say that, but just kind of working on definitions there. 180 is exactly half of a circle, so that would be a semicircle then. Okay, we name a semicircle with three letters, because if I just said AD, you wouldn't know whether I meant go around clockwise or counterclockwise. So semicircles we name with three letters. How big is BAD? Starts at B, passes by A, and ends at D. 230. So if A to D around in one direction is 180, then A to D around the other way is also 180. So we end up with 360 in our whole circle. So if I want B to A is 50, and then an additional 180, that gives us 230 total.
That's just what the questions are in the problems.
Similar. CDA.
How are you able to tell that AD is a diameter? How do you know it's not 179 degree angle?
Because the 50, 80, and 50 tell me it's 180. Without the numbers there, I wouldn't. Without the numbers there, we shouldn't guess that AD is a diameter. But with the numbers there, we can add up and say it's exactly 180.
It's 230.
Yep, that one's 230 as well. It's exactly the same thing, but it's just going around in the other direction. It's still a 50 and a 180. And last one for this picture, CDB is going to be what? How do you figure 280? Okay, so we could do it like the last, take our last answer, 230, and add on an extra 50 to it. Or we could look at, that's almost the whole circle, except for an 80-degree slice. So we could do the whole circle of 360 and subtract out that 80-degree slice. Okay? So in the last set of problems, we were given information about the angles and then asked about some arcs or angles. In this one, you're given information about the arcs, and we're asked about some angles or arcs. So angle GQF would be 60, because Q is the center, so GQF is a central angle, and central angles are equal to the arc. EQF would be 50, because it's going to be a central angle across from a 50-degree arc. GQE would be 110. That's our arc addition or angle addition that we can put together those two arcs next to each other, or we could think about putting together those two angles next to each other. Arc GE. 110 is exactly the same, putting together the two arcs next to each other. GHE, a three-letter name, tells you where to start, where to pass by, and where to end. So start at G, pass by H, end at E, gives you what? 250. I think the easiest way to think about this one is think about the whole circle as 360 and subtract out what we don't have. We don't have the 110 from the last question. EHF starts at E, passes by H, ends at F, would be 310. Again, it's the whole circle except for a 50-degree section. Okay. One more set of questions. I want to look at some questions that you're going to have in your homework because there's a very common mistake here that if you make this mistake, you will get a whole lot of questions wrong. So we want to look at this and try to avoid this mistake.
Whoa.
Hey.
Hello.
Oh, this is a trick.
Triangle.
Crap.
Inside of a semicircle.
Okay, so in these sets of problems, you are going to be given a chart where you will be given one piece of information. You will be given the arc CB, angle 1 or angle 2, and this is where the problem comes in. In the book, angle 1 is labeled as being here. Okay, that's going to be our central angle. Angle 2, the number 2 in the book is floating about halfway between A and O, which makes it a little confusing what they intended to be point 2. It's a bit of a printing problem. Angle 2 is this one that is next to A. So we need to make sure we're looking at the correct angle there because otherwise you might be getting the right answer to the wrong question. If you think that 2 is the other one, you're going to get a whole lot of answers wrong because you were looking for the wrong thing next to A. In the book, it's floating halfway between A and O. So it's kind of unclear whether it means that angle or angle AOC. So let's do an example of this. Let's say, for example, you were given arc CB is 60. How big would angle 1 be? 60, because it's the central angle. Now, angle 2 is not a central angle. Right? It is a special angle, but we haven't defined it yet. We will get to that later in this chapter. So we need to find how we can figure out what that is. Well, you just said 1 is 60. What is the angle right next to the 60? 120. And that's what many students think angle 2 is, okay? But that is not angle 2. What kind of a triangle is AOC? It's isosceles. It's obtuse, but it's also isosceles because 2 of its sides are radii. What do we know about angles in an isosceles triangle?
2
of them are the same. So how can I find out what those 2 are?
Divide the rest by subtract.
Subtract from 180, divide it up equally, and we find that they are both 30 degrees then. Okay? So on that group of problems, make sure that you're putting angle 2 into the correct location so that you can get those questions correct then. Your homework is in section 3 tonight.